Hey everyone, Math 100, we're working on section 2.3 today, mixed numbers. Please start with a warm-up. We're going to reduce to lowest terms, 42 over 48. (42) can be broken up into 6 times 7, 48 into 6 times 8. The 6's cancel, and reduced form is 7/8. So we're going to look at a couple different types of fractions today. The first one is a proper fraction. A proper fraction is a value less than 1. That's just the kind of normal fraction that you'd see where the numerator is smaller than the denominator, something like 2/3. So let's see. Improper fraction, it has a value of greater than, actually technically or equal to 1. So if you had a fraction like 8 over 8, that would be technically an improper fraction because the value is not less than 1. The values, generally though, improper fractions have a value greater than 1 where the numerator is larger than the denominator. And then we have mixed numbers. Mixed numbers combine a whole number and a proper fraction. Only proper fractions though. You can't create a mixed number by combining a whole number and an improper fraction. Your turn number 1. I'd like you to apply these definitions to these numbers. Which one is proper, improper, or mixed number? All right, first one has a whole number included, so that's a mixed number. This one is the value less than 1, numerator is smaller, so this is proper. And 13 over 6 would be an improper fraction. Now for the next example, we're going to write the mixed number 3 and 2/6 as a pizza diagram, and then find the total number of pieces and write as an improper fraction. Okay, so we have 3 complete pizzas, and the denominator of the fraction tells us how many pieces in each pizza. So these will be 6. And now we've got 2 more pieces here, so I'm going to need 1 more pizza here, still 6 pieces. But on this one, only 2 pieces will be highlighted. All of that one, all of that one, and all of that one. Alright, so what we're going to do next is find out how many total pieces we have. So we got 6 here and 6 more, that's 12, 6 more is 18, and 2 more is 20. So we have 20 pieces. And now we can write this as an improper fraction. So the number of pieces goes on top, the number of pieces in each pizza goes on the bottom. So as an improper fraction, we have 20 over 6. So that's another way of writing 20 pieces of pizza, 6 pieces each. Another way of writing 3 and 2/6. Your turn number 2. Write the number 4 3/8 as a pizza diagram, find the total number of pieces, and write as an improper fraction. Now the fraction is 3/8. So that means there are 8 pieces in each pizza. We've got 4 complete pizzas. So these are all good here. And then we got 3 on this one. 1, 2, 3. Let's count up the total pieces. We got 8, 16, 24, 32, 33, 34, 35 total pieces. And so, as an improper fraction, we got 35/8. All right, so in the examples above, we repeatedly added up these whole pizzas, right? The number of pieces in these whole pizzas. So 8, 16, 24, 32. Well, shorthand for repeated addition of the same number is multiplication. So multiplication ends up being a part of how we find that numerator. So instead of going 8 plus 8 plus 8 plus 8, we'll just do 4 times 8. And that's what the whole number is. There's your multiplier. So the procedure then, we're going to start by taking the whole number and multiplying by the denominator, because that gives us the number of pizzas times the number of pieces in each pizza. And then, what did we do? We added on the leftovers, the partial pizza here. And that's the procedure then for changing a mixed number to an improper fraction. First, multiply the whole number by the denominator, and then add the numerator. Right, the sum we found, that goes in the numerator, and the denominator always stays the same. That's never going to change, because we're always talking about pizzas with 8 pieces. So, example, we're going to change to an improper fraction. That is 2 7/8. Alright, so we're going to go whole number times the denominator, so that's 2 times 8, and add the numerator. 2 times 8 plus 7. Order of operations says multiply first. So that's 16 plus 7, add them together and we get 23. So that becomes the numerator. Remember, we're creating improper fractions. The numerator has to be greater than the denominator. The denominator stays the same. 23/8. Your turn number 3. Change 4 1/2 to an improper fraction. All right, we got 4 times 2, that's 8, plus 1 is 9. So 9 becomes the numerator, and as an improper fraction, denominator stays the same, so 9/12, or 9/2. Where we got 12 from. Okay, using order of operations, first 2 steps can be combined into one, and that's basically what we did here. You can always just write it as an expression like this, and then just evaluate it. All right, 4 5/7. So we got 4 times 7, plus the numerator, 5. So we got 28 plus 5, 33. 33/7. Your turn number 4. Change 3 4/5 to an improper fraction. So you're going to do whole number times the denominator plus the numerator. 3 times 5 plus 4, that gives us 19. 19/5. Next up, 8 11/12. So 8 times 12 plus 11, that's 96 plus 11, 107 twelfths. Your turn, number 5, 6 and 3/14. All right, 6 times 14, that's 84, plus 3 is 87. 87 over the denominator, 14. All right, next up we got 23 and 16/17. You may need to do a little side calculation like this. Sometimes you get these double-digit ones, these are a little higher. All right, 23, whole number times the denominator times 17. So we're going to do 3 times 7, 21. Carry the 2. 2 times 7 is 14, plus 2, 16. Second row, 23 times 1, so that's just 23. Add them together and we get 391. 391. So our fraction, then we need to add the numerator, so it's 391 plus 16. And that gives us 407. So our fraction is 407 over 17. Your turn, number 6. 27 and 6/11. All right, what I like to do when multiplying by 11 is multiply by 10 and then add an additional 27 to it. 27 times 10 is 270. If we add another 27 to that, we get 297. So that's 297 plus 6, add them together and we get 303. So our fraction is 303 over 11. Your turn, number 7. Create a pizza diagram to represent the fraction 17/6. All right, well, we have more pieces than there are in a single pizza, so we will need more than one pizza. See, we're doing 6 in each. Now if we get all these, we got 6, and then there's 12. 17 minus 12 is 5, so we still need 5 more pieces here. 1, 2, 3, 4, 5. So all but 1 in this one. All right, so there's our pizza diagram for 17/6. All right, now we're going to write a mixed number representing the pizza diagram from your turn, number 7. All right, so we have 2 whole pieces, 2 whole pizzas, so that's the whole number 2. And then down here we have 5 pieces, 5 more pieces, and each pizza has 6 pieces. So that mixed number is 2 and 5/6. All right, now what do we do here? Let's think about what we actually did. We took a total of 17 pieces of pizza, and we split them up into groups of 6. Now think about what mathematical operation splits a whole into equally sized groups. And now here we had a few pieces that were left over. So think about that operation, and then what do you do if you have leftovers after performing that operation? Alright, so splitting up into equal pieces, that is division, that's our operation, and the leftovers are the remainder. So that's what we're going to be doing, changing an improper fraction to a mixed number. First, divide the numerator by the denominator. Alright, the result is the whole number, and then the fraction will have the same denominator. Remember when we did the conversions from mixed numbers to improper fractions, the denominator stayed the same. The same thing is true when going in reverse. The denominator never changes. Now the remainder of the division is going to be the numerator. Alright, those are the leftovers. And then if necessary, we're going to simplify the fraction to the lowest terms. So let's, as an example, write 17 thirds as a mixed number. So first thing we're going to do is divide 17 by 3. Alright, 3 goes into 17 5 times. We get 15, subtract to get 2. So we get 5 remainder 2 from the division. Alright, 5 is the whole number, it stays the whole number. The remainder becomes the numerator, and the denominator never changes. 5 2/3. Now these are nice, you can do a quick check to make sure we're right. Whole number times the denominator, that's 15, plus 2 is 17. Matches. Your turn, number 8. Write as a mixed number, 13 halves. So divide that out, we get 6 remainder 1. So that gives us a whole number of 6. The remainder is the numerator. Denominator stays the same at 2. 6 1/2. Next up, 33 fifths. So we're going to do 33 divided by 5. 6 times to get 30. Subtract to get 3. We got 6 remainder 3. So that gives us 6 3/5. Alright, I'm going to write that whole number very well. The whole number should be same size as the fraction. I think I'm slipping there. Okay, 6 times 5 is 30, plus 3 is 33, so that matches. Next up, your turn, number 9. So we do 31 divided by 4. That's going to go in 7 times to give us 28, subtract to get 3. So 7 remainder 3. So that's 7. Remainder is the numerator. Denominator stays at 4. 7 3/4. Next up, we got 58 sevenths. Alright, 58 divided by 7. 7 is going to go in there 8 times. That'll give us 56. Subtract to get 2. So that gives us 8 remainder 2 is the answer, and that is 8 2/7. That brings us to your turn, number 10. 59 eighths. So 59 divided by 8. 8 times 7 gives us 56. Subtract to get 3, so we got 7, remainder 3. So that's 7 3/8. Now up till now, all the fractions we've gotten have already been simplified, but that won't always be the case. Sometimes we're going to need to simplify afterwards. 141 18ths. Alright, so we're going to do our division here. 18 is going to go into 141. Let's see, let's do some estimating here to figure this out. Let's suppose that's 20. 20 times 7 would be 140. Since it's a little bit less, that should still fit. So let's do 18 times 7. That's 56. Carry the 5. 1 times 7 is 7, plus 5 is 12. 126. And up here comes the 7. All right. Subtracting, we get 15. And I'm going to bring down anything. No, that's our remainder. So 7 remainder 15. All right, so we got 7. The remainder is 15, so that goes on top. And 18 goes on the bottom. Now notice that the fraction is not in lowest terms, so we're going to need to reduce that. All right, we can factor out a 3 there. Gives us 5, 6. So the final answer is 7 and 5, 6. So this is one of those occasions where your denominator will change, but only because we reduce the fraction. Now the denominator here should match the one we started with. Your turn, number 11. So we'll do 91 divided by 21. 21 will go in 4 times. That gives us 84. Subtracting at 7. So that's 4, remainder 7. So we get 4 and 7 over 21. 7 over 21 can be reduced. Sevens cancel, leaving us with 1/3. So 4 and 1/3. Next example, we got 115 over 35. $15 divided by 35. See, 35 times 3 is going to give us 105. Subtracting at 10. So that is 3 remainder 10. Three and 10 35ths. Now 10 35ths, that has a common factor of 5. There, ending in 0 and 5, using your tests. So 2 times 5 over 7 times 5. 5's canceled, leaving 2 7ths. So that equals 3 and 2 7ths. Next up, your turn, number 12. $154 over 28. All right, 28 doesn't go to 1 or 15. We're going to divide it into 154. This is approximately 30. Multiply by 5, we get 150. So let's try that. All right, 5 times 8 is 40. Carry the 4. 28 times 5 is 140. Subtract, you get 14. So it's 5 remainder 14. So that gives us 5 and 14 over 28. And 14 over 28, that's just 1/2. So 5 and 1/2. Now it's important to be able to convert between these because the different types of fractions are appropriate for different situations. If we're going to do more mathematical operations, then we should leave it as an improper fraction. Because in order to do more operations, if we convert it to a mixed number, we're going to have to convert it right back to an improper fraction because improper fractions are required for doing things like multiplying and dividing. And then mixed numbers, though, they give us more information. It's more understandable. It's easier to see what 4 1/3 is rather than 91 over 21. That's really hard to see with that. It's just hard to visualize exactly what that is. But if we convert to a mixed number, then we can see it's just a little over 4. So if you have like an answer to a word problem and you want to convey a meaning to it, someone who's reading your answer, mixed number is better. If you have more operations to do, then improper fractions are appropriate.